Hello, this is a continuation of yesterday's notes, lesson 13. Today we will be focusing on activity 3. Now, if you recall in yesterday's activity, we talked about looking at the different tables, graphing their lines, and making the connection between the constant of proportionality showing up in the equation, the table, and the graph. So today we're going to continue with that same idea. All right, let's take a look at this activity. So it says Andre and Jada were in a hot dog eating contest. Andre ate 10 hot dogs in 3 minutes. Jada ate 12 hot dogs in 5 minutes. So what we're going to be doing is looking at two different graphs that represent this situation. So we can look at it where we're comparing the number of hot dogs to the time in minutes, or you can flip it, the time in minutes to the number of hot dogs. So let's look at the number of hot dogs and the time in minutes. So if you look at our graph, notice that number of hot dogs is on the y-axis and time in minutes is on the x-axis. So when we're looking at our constant of proportionality, remember that is y over x. So in this case, we're doing hot dogs over time. So on the first graph, it asks which point shows Andre's consumption and which one shows Jada. So if we look a little bit closer, it says Andre ate 10 hot dogs in 3 minutes. Jada ate 12 hot dogs in 5 minutes. So this tells us that Jada's point is going to be farther to the right on the x-axis because 5 is bigger than 3. So that means this point is Jada and this point is Andre. Next, it asks us to draw two lines, one through the origin and Andre's point and one through the origin and Jada's point. So I'm going to go ahead and use blue for Andre and then switch to red for Jada. Next, it asks us to write an equation for each line. Use T to represent minutes, so that's down here, and H to represent the number of hot dogs, that's over here. So let's start with Andre. Remember, whenever we're calculating constant proportionality, it's always y over x. So for Andre, I'm going to do the number of hot dogs over the number of minutes, which is 10/3. Now 10/3 will end up being a repeating decimal, so we're going to leave that as a fraction. You can either do 10 over 3, or it simplifies to 3 1/3. Jada was 12 hot dogs in 5 minutes, so we're going to do 12 over 5, which equals 2.4. So you can use either the 2.4, or you can use 12/5, or you can use 2 2/5, up to you. To write the equation, so it said to use hot dogs for y and t for x, so we're doing h and t. So this tells me my equation for Andre is going to be h equals 10/3 times x, whereas Jada's is going to be h equals 2.4 times x. Next, it asks us to identify for each equation what the constant of proportionality tells us. So this is not just what the number is, it means it's what it means in terms of this situation. So for Andre, it means it takes 1 minute to eat 3 1/3 hot dogs. For Jada, it means it takes 1 minute to eat 2.4 hot dogs. Now, the reason why we know it's 1 minute is because minutes in this case is on in the denominator. So whenever we think of our constant proportionality, whatever is in the denominator is always our 1. Okay, let's take a look. Now, this next situation is flip-flopping it. So instead of minutes being on the x-axis, hot dogs are now on the x-axis and minutes are on the y-axis. So if we think back to our original equation, our original information, it said that Jada ate 12 hot dogs in 5 minutes and Andre ate 10 hot dogs in 3 minutes. So now for this round, our y over x is going to be the minutes over the number of hot dogs. To figure out which dot belongs to each person, we look at our number of hot dogs. So Jada ate more hot dogs, so her point is going to be farther to the right. So this point is Jada, which means this point is Andre. I'm going to go ahead and draw my line. Hopefully I can keep it straight. So there's Jada. I'm going to switch to blue for Andre. There's Andre. Your lines will be able to be straighter than mine. So again, we're doing y over x, which is minutes over hot dogs. So to figure out the equations, the first thing I need to do is figure out my constant of proportionality. So for Andre, it took him 3 minutes for 10 hot dogs, which simplifies to 0.3. For Jada, it took 5 minutes for 12 hot dogs, which is not a very pretty decimal, so we're just going to leave that as 5/12. Again, I'm using h and t for our time and our number of hot dogs. So x is going to be h, and y is going to be actually t. So my equation for Andre is going to be t equals 0.3 times h. So that means it's 0.3 times the number of hot dogs, and that'll tell us the time. Jada is going to be t equals 5/12 times h. Again, the time is equal to 5/12 times the number of hot dogs she eats. The constant of proportionality, so instead of it being per 1 minute, it is now per 1 hot dog. So we would say it takes him 0.3 minutes to eat 1 hot dog. And for for Jada, it takes her 5/12 of a minute to eat 1 hot dog. So whenever you're trying to decide which is your value of 1, it's always what's in the denominator of your ratio. So if you think back, we said our ratio hot dogs were in the denominator, so therefore that's going to be our 1 value. So the key thing to realize here is that each situation had 2 different constants of proportionalities. So for example, Andre had 3 1/3 in the first situation, but 0.3 in the second situation. So both of these constants of proportionalities do represent the situation. The big difference is that in our first situation, we were figuring out per minute, whereas in the second situation, we were figuring out per hot dog. So that's when the constants of proportionalities change. You may or may not have picked up on that those are actually reciprocals of each other. So hopefully you did notice that. So if you look back, we had 10/3 here and then 3/10. And for Jada, we started with 12/5 and then moved to 5/12. So it kind of connects back to what we talked about, how every situation has 2 constants of proportionality. One is based on the situation, and then the other is is the reciprocal. So they still relate to both. They relate to the same situation, just 2 different ways of writing it. So let's go ahead and take a look at the summary. So in this summary, it says you have a leaking faucet, and it leaks at a constant rate of 2 minutes for 10 milliliters. So every 2 minutes, it leaks out 10 milliliters. It says there is a proportional relationship between the amount leaked and the time that has passed. So remember, based on what we talked about, we could represent this situation 2 different ways. We could represent it as the number of minutes over the number of milliliters, or we could represent it as the number of milliliters over the number of minutes. Based on which way we represent it, it's going to change our constant of proportionality, and it's going to change what our x and y axis is. So if we look at the first graph, if we're doing minutes over milliliters, remember we're still doing y over x, this tells me my y-axis is going to be the time, and my x-axis is going to be the volume. So please make sure we're labeling this x and y-axis, because you will have to do this on the cool down. They got 1/5 as the constant of proportionality, and they got that by doing 2 over 10, just pulled from there, 2 over 10, which simplifies to 1/5. Now when we look at the second table, this one, or second graph I should say, this one had milliliters on top, so that means the volume is on the y-axis, and minutes or time on the x-axis. So again, it doesn't matter which way you go, just make sure you're labeling what your x-axis is and what your y-axis is. They got the constant of proportionality for 5 because they took this ordered pair. They did 10 over 2, and that simplified to 5. So when you take the cool down, remember, you could have a possibility of 2 different graphs. Your graph, the way it looks, is going to depend on which you label as y and which you labeled as x. So when you complete your cool down today, the situation is talking about ounces of popcorn versus the cost of popcorn. So you need to decide, are my ounces going to be x, or is my constant going to be x? It doesn't matter which one you do, but whichever one you do decide on, make sure you find the constant of proportionality by doing y over x. So that's it for this lesson. You can go ahead and pause the video. If there's still time left in class, you can go ahead and get started on the worksheet for homework. At 11:30, Mrs. Hurley will be stopping you, and you will begin working on the cool down.